Okay, in this video, we're going to work a problem that falls under the category of particle equilibrium. In particular, this will be a 3D case. When comparing the 3D case to the 2D case, the physical principles, the physics, is exactly the same. The way you interpret the free body diagram, the way you analyze everything, it's exactly the same. The difference, what makes the 3D problem more challenging is that you have to work with 3D vectors. But again, all of the physical principles, how you interpret, the forces in cables, springs, how you interpret the free body diagram, it's all exactly the same. Okay, so this problem says that cables A, B, and AC can sustain a maximum tension of 500 newtons. So cables A, B, and AC, and the pole can support a maximum compression of 300 newtons. Determine the maximum weight of the lamp that can be supported in the position shown. The force in the pole acts along the axis of the pole. Right, so we haven't talked about, if we had a pole here, this could support bending or twisting. This isn't a spring, but they're telling us that the force in the pole acts along the axis of the pole. And we'll see that in future lessons, we'll see that we technically didn't even need to be told this. We would know that the force in this pole has to act along the axis of the pole based on the problem. And we'll talk about this later, but it's because this is a two-force member. There's only two forces acting on this pole. So because of that, we know that those forces must be acting along the axis of the pole. And we'll talk about that later. So for particle equilibrium, we want to draw a free body diagram on a component that's like connecting the system together. So the lamp here, we're relating the weight of the lamp to the forces in this pole and these cables. So they all meet at this point here. So we want to draw the free body diagram of this point A. The line of action of all these forces meet at point A. So there's our point. And we'll go ahead and put our coordinate system to where the origin is at this point. So now we can draw our forces. All right, so the weight of the lamp is acting down. And technically, since this is an unknown force, we don't have to get the sense right. And the final answer would, if we put the sense going up, that would be fine. And then the final answer, we would get a negative result for W. And we would know that its actual direction is opposite that. Well, we need to get the sense that the known forces we're going to have to get right. So the sense we're going to have to get right. And so this is a little bit confusing because of the way the problem is stated. But so the compression in the pole, the pole can support a maximum compression of 300 newtons. So we're not going to put, the line of action of the force in the pole is in that direction. And based on they tell us that the pole is in compression, so we know that as far as point A, it's pushing on point A in this direction. But we need to get this sense right here because whenever we're not going to put 300 right here, and you'll see why later in the problem. So we're just going to put FP, so force in the pole. So this kind of seems like an unknown force because we didn't put 300, but this is going to act as a known force because once we get our equations, we're going to end up substituting in this 300. So it's going to be kind of like a known force. And so when you have a known force, you have to get the sense right. Okay. So then FAC is acting in this direction, and cables can only support tension, so we know it has to be pulling like that. It's pulling back on the point. It's pulling the point A in this direction. And so cable AB can support a maximum tension of 500 newtons, but we're still just going to put this as just a variable. And again, you'll see why later in the problem. But the sense needs to be right. If you ever take your equations and you input a a force, like you yourself input a force, then the sense needs to be correct. If it's an unknown force and you're solving for it, then the sense doesn't have to be correct, and the final answer being negative or positive will tell you the correct sense. Okay, and then so FAB, it's in tension, so it's pulling. Okay, this is FAB. Okay, and we usually, with free body diagrams, you usually want to put the dimensions, but we'll just reference this. All right, so now we just want to further define our forces, their magnitudes and directions. So the force vector of W is what? This is negative W K hat, right? Okay, the force vector of the force in the pole. So this one is pushing on the point. So we start at point O and go to point A for our direction. So we'll have the magnitude of FP. And now starting at point O and then going to point A, we go 2 in the I, positive 2 in the I, minus 3/2 in the J, and then plus 6 in the K. And then if you square each of these and add them and then take the square root, you get 13/2. So what you're left with is 4/13 I minus 3/13 J plus 12/13 K. So that's the force vector of the force in the pole. Now let's do the force in AC. So we're going to bold this because this is the force vector, and the non-bolded is the magnitude of the force. Okay, so now we're starting at A and going to C. So we go 3 in the I, or no, we go minus 2 in the I, and then positive 3 in the J, and then minus 6 K. And the magnitude of this vector is 7. So we're left with minus 2/7 I plus 3/7 J minus 6/7 K. All right. Okay, force vector FAB, we start at A and go to B. So we go minus 6 in the I plus 3 in the J minus 6 in the K. And the magnitude of this vector is 9. So minus 2/3 I plus 1/3 J minus 1/3 K. All right, so now we've got our free body diagram and our forces fully defined. Now we can do our force balances. So sum of the forces in the X are equal to 0. So 4/13 FP minus 2/7 FAC minus 2/3 FAB equal to 0. Sum of the forces in the Y are equal to 0. Minus 3/13 FP plus 3/7 FAC plus 1/3 FAB is equal to 0. All right. Now, sum of the forces in the Z are equal to 0. You've got minus W plus 12/13 FP minus 6/7 FAC minus 1/3 FAB is equal to 0. Okay, so 4 total variables in 3 equations, but we're given some information where we can input a value for one of these variables. But we didn't usually we would put that information in from the very beginning. You'll see here, you're going to see why we had to wait until this step. So let's take our equations. So you might be tempted to say, well, let's input FAC is equal to 500, FAB is equal to 500, and FP is equal to 300, and then solve for W. You know, we could just do that here, take this equation and do that here. That wouldn't give you an accurate answer because all of these aren't going to be, like, if the force in the pole is at 300 newtons, that doesn't necessarily mean that the tension in AC and AB are both at 500 newtons, right? You have to look at it like the different scenarios. If the force in the pole is at 300, the compression in the pole is at 300, then what is the resulting? Then what does that mean that FAC is equal to and FAB is equal to and the weight of the lamp is equal to? Then you have to look at the case. Well, okay, if the tension in AC is 500, then what is the resulting compression in the pole, the tension in AB, and the weight of the lamp? You have to look at the cases. Okay, so let's look at case 1. All right, we're going to say that FP is equal to 300 newtons. Okay, so the force in the pole is 300. Now let's solve for all of the other forces. So let's first look at these. Let's look at these first 2 equations. We can subtract or add these 2 equations, but before we do that, we need to have one of the terms equal. So let's make this a 2/3. So then these will cancel out. Okay, so we've got. Now let's multiply this second equation by 2. So we get minus 6/13 FP plus 6/7 FAC plus 2/3 FAB is equal to 0. All right, and now we just want to add these, not subtract, just add them. And we get 4 minus 6, so minus 2/13 FP, and then minus 2 plus 6, so plus 4/7 FAC, and then these 2 subtract to 0. All right, and so now let's solve for, we've got FP, so let's solve for FAC. So FAC is equal to, we'll have 2/13 times 7/4. So we get 7/26 FP. Okay, so FAC is 7/26 times 300. Okay, so 80.8. All right. And so, well, first we can check. So that's FAC is 80.8. So that's okay. Like it was possible that we would get FAC is equal to 750. And so that which is above 500. So in that case, the force in the pole can't be 300 newtons. You see? But as of now, checking FAC, we could have a force in the pole of 300 newtons. But let's find out what FAB is. Okay, so let's take this first equation. So 4/13 FP is 300, 2/7. Okay, and this is equal to 2/3 FAB. Okay, so 4 times 300 over 13 minus 2/7 times 80.8. Okay, so this is 69.2. So that means that FAB is, and so take this, multiply it times 3/2. Okay, so 103.8 newtons. All right, and so that's not greater than 500. So we can have the scenario where this force in the pole is under the maximum compression load that it can support, and that won't overload the cables. Okay, so in this scenario, what is the resulting weight of the lamp? So W is equal to, so 12/13 FP is 300 minus 6/7 FAC, and then FAB. Okay, 300 times 276.9. All right. Okay. Okay, and I'm just noticing that this here, minus 6 divided by 9 is 2/3. So this should be 2/3. This should be 2/3. This should be 2/3. Okay, and that doesn't affect the work we did here because we were working with just the first two equations, but that just changes this. So this should be so okay. In this case, we've got our W is 138.4. Okay, so this is a for the scenario where the pole is under the maximum load it can take. This is the weight. This is the weight of the lamp. All right. So what about the case where? So let's just start here. So case 2. Let's say that FAC is under the maximum load. So FAC is 500. Okay. In that case, if we take this formula, we say that FP is equal to, so 26 over 7 FAC. Okay, so FP is equal to 1857. But okay, so but look at this scenario. If this cable AC is under a tension of 500 newtons, that would mean that the force, the compression of the pole is 1,857 newtons. That's over 300. So FAC can't be loaded to 500 newtons. And you might say, well, okay, what about if it's loaded to 400 newtons? No, we know that. So FAC here, if FAC gets bigger than 80.8 newtons, so let's say, okay, like let's come up here. You see, you can take the FAC terms and you can take the FAC and the FAB terms and put them on the opposite side of the equation. They're adding up. If you keep the force in AB constant, well, actually, let's leave it like this. Let's look at just this form, like with 0 on the right. If you keep the force in AB constant, if FAC rises, FP is going to have to rise because you need to sum the 0. But FAC could still possibly go above 80.8 because then FAB would then shrink to compensate for that. I mean, we can see, so what would FAB, in this scenario, what would FAB end up as? So 2/3 FAB is equal to 4/13 FP minus 2/7, and then, okay, so 571.4. $142.9. Yeah, so this is going to need to be, it's going to come out to a negative number, but that's not even possible because if the force in this cable, we're pulling at 500 newtons, this would need to be in compression and this would need to be in compression to support that. So that can't happen. So you can run through all of the scenarios, but all we're going to need to do here is look at the cases. So like just plug in the maximum load in the rod, plug in the maximum load in each of the cables, and then solve independently for the forces and see what happens. So case 3, you've got FAB is equal to 500 now. So maybe if AB is under max load, that's a system that allows the lamp to be even heavier than this. This is case 1. Okay, so in this scenario, let's take this. So we want to add or subtract these two equations, but now we don't want to get rid of FAB. We want to get rid of, let's say, FAC. So we'll multiply this equation by 3 and this equation by 2. So we get, okay, minus, so then this will go to 2. Okay, and now this equation you multiply by 2. Okay, so now let's just add these two equations, and we're left with, and then minus 2 plus 2/3 is, so minus 6/3 plus 2/3. Right, so we got FAB, well, this is equal to 0. So we want to say that FP is equal to, so 4/3 times 13/6 FAB. So okay, so FP and then FAB, so 1,444 newtons. And same thing, this is not, we can't do this. So that's our 3 cases. Only case 1, is you can only case 1 applies. You can't load these cables at their max tension. You can only load this pole to the max compression that it can hold. So in that scenario, that's the largest weight lamp. You can keep increasing the weight of the lamp until this pole gets to its maximum compression value, and that weight is 138 newtons. And that's the answer.